Good afternoon to all of you. Does it work? Very audible? So first of all, let me thank Fujitsu to invite me to do this invited talk. And here I will be speaking of more semiconductors. Maybe many of you do not come across semiconductors and what we are doing in your own world, which is, I should say, really at the cloud level, doing IT, getting these services and so on. So, but you know, here I will show you that where actually the rubber is meeting the road and which are those devices in this new world which is changing. So some of these slides you may find that they are pretty ST-centric, and some of them you may find that, you know, I am speaking of market share of ST, but believe me, these are not for marketing purposes. These are just to show you that the reality and how it is moving in that direction, right? That is the only purpose. Okay, so I will be going a bit faster, at a faster pace, so please stay with me. So first of all, let me speak about that what we are going to share in this presentation. In fact, it is the last line, that what semiconductor is playing a role here. But the reason of picking up the last line and focusing there is all in the above lines. So if you see the first one, smart world, now we are all, everyone is speaking, everything is smart, right? We probably don't remember that smart cards was maybe the first thing which we started to say as smart cards, right? So SIM cards long by back. But now, smart world, and this is definitively, we can see that is the interplay of ecosystems. There is a discrete change. In the past, we could have done something in our domain, being silos, we could have given to the next guys and then be happy with it. We have made our business, we have done our revenues, but in this new world, as we will go through, is not going to be so straightforward, which is a challenge as well as on the other side a huge opportunity. And I believe that this, and we saw in previous presentations, there were glimpses that there is going to be a need of collaboration all across, not just as suppliers and customers, but even going much beyond than that. Then IoT in itself is bringing a wealth of opportunity. First is like an ocean, sky. If we can dream, we can do the things here, and it would be, I will try to bring you a little bit closer to this reality. And the third one I spoke about already, so there would be change in the value chains. For example, in the past, we were just giving the components. We may need to provide now solutions, and why not some services there, which we have not done before. Similarly, I believe that the IT companies who were providing the top-level services, maybe they need to integrate better so that fuller solutions can be provided. So I think that those boundaries would be challenged and readjusted, and the value chains will also shift. Now we are in India, and I can really share my feeling that IoT is an opportunity which is really meaningful for India, and during the course, I will speak more about it, but I believe that this is one opportunity where we need not to lag behind the world. In fact, we can be quite contemporary and developing it at the same time. And we will see the last line more clearly. Let's now, just 2 slides on ST so that you know that who am I. So I am managing operations of STMicroelectronics in India. And the company, last year we did close to $7 billion. So it's a worldwide semiconductor company with 43,000 employees. We are integrated device manufacturers, meaning we do the design of chips, we do manufacture it within the company, although we use some people from outside, but nevertheless, there is integrated device manufacturing, right? Both front end and back end. And then on the innovation edge, you can see that there are very large number of product families, very close to 10,000 product families itself, and the number would be even larger. In India, we started, next year we'll be completing 30 years. So this is our building in Greater Noida, and we have more than 1,000 engineers present today, and you know, serving the local market, learning from it, and also bringing the solutions here, but more importantly, also using the R&D center to cater to ST's needs worldwide. Now, let me step more deeper. So here I share with you company's strategy, but once again, here I am using ST and ST's strategy just to point out to you some of the directions which semiconductor companies are taking. First thing you can immediately notice is that is smart. So it's not only the buzzword, we are using it, is in our bloodstream now coming in. So there are two pillars. One, we are speaking of smart driving, and maybe you will be a bit surprised that why we picked it outside the other smart stuff, which is more IoTs, where you have smart industry, you have smart city, home, and smart things. The reason being that smart driving in itself is really bringing a plethora of opportunities. And I will highlight as we go further on that. So, first of all, next 4 slides will give you a feeling of how business is growing. I would like to mention one thing. Whenever there are changes in the industry, many times there are new opportunities are created. But most of the time, there is a transformation. There are things which are being done in a way, and then new technology comes. We start to do things, similar things, but in a different way, but much more meaningful, much more intelligent, much more smarter, right? So therefore, in these charts, if you look at that with the smart stuff coming in, one block which is really going to grow. So this is 16 and 19. Just to explain, these 2 bars are showing that what was the revenue or the SAM. SAM is the available market. This is the market size in 16 and in 19. So one big point there, you will see that safety is going to go up. Why? We can anticipate easily. We are speaking of driverless cars, autonomous cars. If that has to happen, then the safety of the car is extremely important. Then you are seeing another bar which is coming quite strongly is the powertrain, where basically means that you will have all the electrification, the engine control. First, we are all now doing the efficiency of the engine, reducing and bringing more, kilometers per liter, but then it is going to become electrical vehicles, and that's where it is going to have a huge growth. But nevertheless, all the lines, be it infotainment, be it body, be it, chassis, all of them are going to grow. And smart stuff is going to play a major driving role there, and I must say that it is already doing it. It's not that we are speaking of some fiction, that it will come later. It is happening, and we are seeing the traction there, and I will show you a few more. Smart industry, similar stuff here. So automation is going to have a big kick here. Automation within the industry, smart manufacturing, robotics. We heard something about robotics in the previous presentations, but I can share with you that we are able to see that. And in India, by the way, you know that electronics manufacturing, and that's why Make in India program is such a huge program. And electronics manufacturing, we don't do it. 65% of our electronics components we are importing, which is a pity. And electronics can be done here. And if you go and visit many places, you will find that the equipments which we are using are really not state-of-the-art. But I was pleasantly surprised when I was visiting one of our customers in Bangalore. He has set up a brand new electronics manufacturing, fully robotized. Is manufacturing set-top boxes, all robots. And here, only a very few people are needed to run the whole plant. Good news is, great, state-of-the-art, good quality, reliability, but we may also speak about that what will happen to our 60% farmers who are dependent upon 18% of GDP of India, where they are going to migrate. If robots are going to come sooner than they are expected, what will have the implications on the job market? These questions would remain, but I think in the past, when computers first came, same questions were there at that time. What will happen? Then jobs transform, new jobs appear, and things change. So those things all we have to see. So automation is important. Medical, we know very well. Similarly, in aerospace and defense, there is going to be growth, and we will see that many of these smart things are entering there. Another big area is going to be smart cities. Once again, referring back to India, 100 smart cities to be done. What really is a smart city? I believe that such questions will probably never settle to a very finer blueprint, but overall we know that whatever we can manage better, and one of my colleagues was giving that if it is self-sustaining and like transportation can be managed better. In India, we have lots of troubles when people are coming the wrong side, if they can be automatically detected, right? And our office is in Greater Noida. So when we go from Noida to Greater Noida, there are now automatic speed control cameras there. Initially, everyone will overspeed. But now as those cameras are there, no one crosses 100 kilometers. And my taxi driver once told me, sir, there are only 2 cameras in the whole road. If you know where are those 2 cameras, you can overspeed in between, right? So sure, things are smart, but people are smarter, and they should remain so, right? We should not outdo them. That is the beauty of it. So we will see that all this smart metering, even if it is showing relatively less opportunity, but for India, this is global, but for India, it is a big opportunity where for many utility companies, 60–70% of electricity is lost while transmitting itself, right? So if there are smart metering, better way to manage it, and that's where you may have heard that our energy minister, Mr. Piyush Goyal, was saying that make a smart meter at 999 rupees. Now, 999 rupees is really shivering, right? So, but they say that when we started with LED, it was 350 rupees in the market. We said 90 rupees, and the bids came, and finally it is now even 40 rupees. I think those are really with masses how things change, but my caution, and I mentioned to government also time to time, that in pursuit of bringing down the costs, we should be careful with the quality. Now we see that all the time our calls drop. Right, so it's fine, we are paying a bit less, but then many times we are not able to call either. So therefore, there is a balance to be done here. But nevertheless, these things are what will make smart cities and smart homes within our homes, right? We will see more and more incident. I think this is happening and a wave is coming. I have started to see some homes which are getting equipped with these smart things, which really can see and sense and measure. So let me continue. Then finally, I think this is the most known, that smart things. Anyway, they say that mobile phone tablets are also smart, which I completely agree. It's not that we need to discard and start counting smart from somewhere else. Then fitness bands, health bands. Tomorrow, I think this watch would be purely really a medical stuff, which we will be wearing. So these things, but big opportunity if you see that from 16 to 19, there would be 30 billion devices. Now, one point here is there, that if 30 billion devices are connected, definitively our previous models of working is going to collapse, because these are devices which are connected. When they are connected to somewhere. And take the example of power inverter. In India, we still have electricity shortage, right? I hope in Gurgaon it is better, right? But answer looks no, right? So still we find that the power goes away. So a power inverter typically used to be a standalone device. No really need of any services there. But tomorrow it would be connected. So when it is connected, the supplier can check what is the condition of it, can do lots of things, can also judge your behavior and so on, and can provide related things there. So therefore, it will now go beyond what was just a semiconductor components given to an electronics manufacturer, and that's it, right? So that's where the boundaries would be challenged, and that's where, once again, I repeat, the need of collaboration is very stronger across all the stakeholders. This is just the view, same thing. We start with the smart things or simple things. There are gateways, and then there are servers here. That's where the ecosystem is laid out like that. And therefore, when we need to do any business model, we need to keep all this in consideration. And by the way, that is also one of the reasons I am here today with Fujitsu to see. We saw a lot of things happening here. So I am bringing here a lot of things on the other side, right? So we need to see that how we are connecting and how we are collaborating better, that these things finally take good shape. Now, let me start. I am sure all of us are aware, but even just for the sake of repetition, what we call really a smart thing. So here I am coming from the thing point of view. So typically, it's easy to remember 5 fingers. First, it should be able to sense. We may ask also the question that suddenly, how come all these smart things are happening now? What has changed? Microcontrollers were there, processors were there, all these things were present there. So what are the changes which are happening? Then someone say that, okay, it is internet also, which was not the case. But I believe apart from these, which are true, there is one important aspect. Today, things are able to sense on their own. In the past, things were not able to sense on their own. They needed a human being, right? If there is a movement, right, we were not able to do that. Now, again, the technology of checking the movement is not new. When I joined 30 years back, my previous company, my first job was to monitor the health of the machine by putting accelerometer or kind of, it was like doctor's stethoscope. You put it on the machine, it will see how machine is vibrating. If everything is good for the machine, it will vibrate on a Gaussian distribution, that is the law. If there is something wrong, it will not vibrate with Gaussian, right? So it was there, we were capturing whether, so this could have used for industrial automation, and we could have called very well, that is the new wave of smart industry automation. But the only problem was, we needed to import it from Denmark, and it was costing one device 20,000 rupees. So the big change is that these devices are now miniaturized, and they are very cost effective, and therefore they can really proliferate in the masses, which was not the case before. So things are able to sense. Then of course there are processors, and they are intelligent in that sense, that they can process the data. Then we have all plethora of artificial intelligence, which maybe I will just spend one chart on that. And then we need them connected also, right? That is trivial. What is not so obvious is power management is extremely important. Your mobile phone, we would not like it to be drained like anything, but even much more intricate for the things. When there are going to be 30 billion devices all connected, if they consume a little bit more, there would be huge impact on the environment, but also, how to charge them is going to be important aspect. And finally, with all the data traveling everywhere, the security of all this is going to be extremely important, right? So these 5 things, if we put together, at least the core of being a smart thing starts to emerge. Then there are many things we need to put on top of that, but at least these 5 things are important to make a thing which is smart. Form factors are different. They will appear in various forms, depending upon where their application and use is. But at the back, it is simple. Thank God it is not so complex. At the back, this just needs those 5 things. Once again, explained in a bit detail: processing, sensing, connectivity, and also some signal protection, and finally power management, right? So fundamentally, those things stay there. And that's where semiconductors provide the solutions so that we can construct all our Internet of Things on top of that. So I use one ST slide. So here, when I am speaking, ST is actually able to provide all those 5 elements together, and that's where we believe that IoT is a huge business opportunity. And if you go back to ST's strategy, that is the reason, because we have those elements, we believe in the smart world, that we are much more geared to participate in a stronger way. Let's continue. I just gave you some examples of the sensors. We know it: motion sensors, environmental sensors, pressure sensors, UV index sensors. All kind of sensors are there. Technology is there, can be produced very cost effectively, can be miniaturized, can be put in any kind of applications, right? Then, if I take one example of flight sense, what is a flight sense? You see that how little technology there makes our life difference. It is basically beam a photon, let it go to the object, come back, compute the timing, and see that how far the distance is. Once again, nothing new. This has been done since long time in the world, but now it can be done in a chip, very cost-effective way. And the applications are as simple as when you are doing an autofocus of your camera, it goes in and out, takes a while before you have the focus. But with this, 0.3 milliseconds. So it means that these eyes now, or these things can be given to robots, and if they have 2 cameras, they can create 3D vision pretty fast. Otherwise, it could have been nightmare, right? So that's how those little things start to make the change. And this is one example of the sensors. And then, just to share with you, after Pokemon Go there, suddenly our book orders are overflowing for sensors. So our factories are running overtime to really meet the need. Somehow this Pokemon Go is pushing this. So the virtual or augmented reality, which is based on these elements. So once the applications are there, they really boom. Okay. Now drones, right? So we start to see also in India somewhere here and there. How come they are becoming accessible again? The answer is the same what I have already provided you. Things are available, gyroscopes are there, they can do the stability. We can put so many microcontrollers. Still, it will not become awfully expensive that it is beyond the reach of common people, right? Like, kids and all is not only for industrial use. So putting all these things, you can imagine that there is an explosion of opportunities which is arriving. These are some examples which so far we are able to conceive, but with those building blocks, you can imagine that limit is our imagination, right? So you can construct many, many more things there. Then, just to indicate to you, to really share a bit of semiconductors behind, we have microcontroller, which is really an important piece. There, the need of the microcontroller is different. Sometimes we need very low power, and sometimes we need very high power, right? So once again, then all the companies who are operating in this, they need to provide those solutions so that these kind of devices can be built. But check one thing, that there is going to be huge variety. And that is the complexity, that is the opportunity, that is the challenge. Okay, connectivity. As once again, another difficulty in IoT today is that standardization is not fully done, and maybe it will never be fully done. Because the day we do it, we will be specific to a particular area, suddenly another new area will open, right? But never, it would be needed for interoperability. So we need to gear up to be able to provide various different kind of connectivity needs which may be needed there. Similarly, for power energy, it could be energy harvesting. Pretty soon we will be having wireless charging in your homes, right? So these wires, once we would be used to wireless charging, believe me, it would be very hard to come back to wires. And that is the direction which is being taken. You have already heard with the announcements of Apple, right? They are going to do away with the wires. And then once again, it is semiconductors behind the scenes which is enabling it. Energy harvesting, right? Wherever, it could be in our homes, could be in the industry, could be in the street lights. To effectively harvest energy and to supply to our devices is going to be the key, and we need to have all semiconductor solutions to enable it. Finally, last but not the least, is the security. When we are putting everything there, machines are making decisions. You would not like that there are security breaches, right? So if my home, I am able to see every room of my home in my camera, in my phone here, I would not like that someone else is also able to see it, right? So there the need of security level is different. Somewhere it is really basic, but somewhere it is pretty high. For example, for banking, for identification, that's where we would not like that there are security breaches. Once again, semiconductor companies have to supply solutions to cater to this challenge when there are billions of devices that at the end, there are no security breaches which are happening there. So this is the fifth element which I have explained to you what is needed for the IoT. Now, to enable this, to help our customers, to help our partners, we need to provide software, we need to provide hardware, we need to provide solutions, platforms. That's where the abstraction level of our handover is changing. In the past, we were handing over the devices, but now we need to hand over the solution. And with solution, even services. What kind of services? This is an open question, right? So that's where I think it would need lots of work together to understand how it goes. So platforms, I mentioned already that general purpose, secure micros, all these kind of platforms are available. Now let me come to my next session, which as I mentioned, that on smart driving, right? These were all smart things, but let's focus a little bit on smart driving. So first of all, the market is impressive. There are 87 million cars, which were in 2014. They will go to 113 million. In India, we are using 3 million cars, passenger vehicles every year. China, close to 20 million. So we need to imagine what will happen to Gurgaon, right? When we will be selling 20 million cars per year, it is going to really be much more, not only Gurgaon, right? Even Noida, Greater Noida, we are getting congested there also. So it's not only a matter of one city or the other one. But nevertheless, this is a great opportunity. And then the content of semiconductors per car is also growing. So it is estimated that by 2022, there would be something like $333 of pure semiconductors inside an average car, which typically costs about $10K worldwide. But situation is quite different if we start with the average car, which is $330, but if we go to the premium car, then the semiconductor content is touching almost $1,400. And if you notice here, majority is electrification and ADAS. ADAS stands for Advanced Driver Assist Systems. Driver assist. When you say autonomous cars, driverless cars, we need all the assistant to the drivers, right? So that is another major. So two blocks you are able to notice, electrification and ADAS. Those are major pieces which are actually getting into premium cars, but they will also enter into the basic cars as a proliferation of this happens. So then we'll see that even maybe $330 is a bit less, right? So this is just one slide on STMicroelectronics. So excuse me if it looks like a marketing slide, but nevertheless, we have 30% of our revenues in automotive, and then you can see that we are world leaders in many of them, and we have globally 9% market share in this. So when I am speaking about cars, smart driving, the purpose of this is that this is already happening, and we are there at the forefront really to make it happen. Okay, so there are three elements in the car which is changing. First is that cars have to be made safer, more connected, and finally greener. Are they completely independent of each other? No. With more connectivity, actually we can make cars even more safe. For example, that if there is an accident ahead, 2 kilometers ahead, and if the car is connected, it will be beamed that be careful that there is some accident down the line, right? And you can automatically stop the car or can do something about it. So once the connectivity is there with the car, suddenly the game changes. Like aircrafts, imagine that if aircrafts are not connected, can we still be able to do autopilot and, pilots can enjoy the situation there? It would not be possible. Similarly, if we are going to think, and there are now driverless or autonomous cars going to happen, they need to be connected. Otherwise, it would be a very hard problem to solve. And finally, the greener one, by the way, here again, the connectivity plays a role. If you look at eco navigation, I think now most of us are using Google to see that which road to take. And where there is less congestion, follow that. It saves times, it saves fuel. So this is what we are using every day, right? So hence, they are not really mutually exclusive or independent of them. They are pretty connected, safer, connected, and greener. Let me just show you some examples of that. Today, a modern car is fully fitted with all kinds of sensors. Sometimes we may not be aware, our airbags and or our electronic stability, anti-theft systems, they are all full of sensors. So that's why car is a very important thing. See, in the past, we used to say 3 basic human needs. And in Hindi, excuse me, gentlemen, I can use a little bit of Hindi, right? So in Hindi, we used to say roti, kapda, makan. But I will add 2 things there, mobility and connectivity. So 5 basic things, and therefore all these MEMS and sensors are entering into car in a big way, and they are present, as you can look at this car, in multiple places. And then ADAS system is very interesting if we look here. First of all, there are cameras in front, in back. So there are 2 issues to be solved. One is that car should be self-aware. So we have put 2 radars. One is the short-range radar, which can scan the car around 360 degrees, can know what is happening around the car. And then there is a long-range radar. So with the long-range radar, we can see from far that what is going on. In case a pedestrian is jumping on the road, right, the car can know it with this system, right? So cameras, radars, sensors, and then of course all the micros and so on, putting together, this is what is enabling this autonomous or driverless cars. Otherwise, you can imagine without this, this would have not been possible. So this is ST's roadmap. Just one comment I will say, if you look on the left side, that the growth, this is our billing, ST's billing, and you can see that in this particular field, how this growth is happening in the last few years. So here we can get a real feeling that things are really moving. It's not that this is just a fiction and it is not business. It is business. And then, I indicated there are short-range radars, long-range radars. Will not go, let's say, more detail. There are cameras which can do all kind of things. You can look at this sheet. There are cameras in front, in the back. It can provide you all the vision in your dashboard. And then, more important is that the vision processors are there, which are, see, this is car, call it car vision. Like we say, machine vision, human vision, this is car vision. So there is a processor dedicatedly done for this, which can construct that what is happening in and around the car and can give the view to the driver so that the car can be driven safely even if it is driverless. Connected, we discussed. One terminology I would share with you, if you are not aware, is called V2X. V2X stands, first V is clear, vehicle. Then connectivity is from vehicle to whom, that is X. X can be V. When X is V, then it is V to V, vehicle to vehicle. When this X is I, which is infrastructure, then we call V to I. And when this X is person or pedestrian, then we can call it V to P. So it means car is connected. So if it is connected with smartphones and so on, it can even communicate with the pedestrians, right? And imagine that when cars are able to talk to each other, they can collaborate for a cruise speed. They can say that, okay, guys, there is lots of traffic. Let's keep a limit of 30. You also remain at 30, I also remain at 30, right? And maybe then they can go further, right? So this is the beauty of V2V and, similarly of a V2X. So this is, once again, this is there now in the cars. And then we have product also. So you see on the right side, this is ST product, which is enabling auto talks, as it is called. So these solutions are available and being used by our customers. Finally, let me come to the electrification. One of the best ways to make the cars greener is to do away with all the petrols and diesels, right? So that's where electrification, but we should do it very efficiently. And that's why you see here that there are technologies, silicon carbide, for example, is a technology which we are using to make our devices, which will bring lots of efficiency. For example, when power has to be delivered on the top, it would be 20%. When mileage has to be extended to manage the batteries correctly, it will provide 8% increase over there, and then form factor for other power control units of 5. So these technologies, semiconductor people are working very closely and developing this so that electrification of the vehicle is a possibility to make the cars greener. Final word, we cannot forget about security. Security here is very critical. We need to have secure elements at all the places, be it at individual level within the car or at the gateways or finally to the cloud. If it is not there, then we can imagine, I am driving a car, let's say it is a driverless car, but someone else is driving whom I don't want that he should drive my car, right? Or whatever. So therefore, security is extremely important, but as you see, once again, semiconductor companies are already providing solutions here, and lots of focus is there to beef it up so that these things remain in place. Let me come to my last two slides, artificial intelligence. So I have deliberately kept it as a white space. And the meaning is that, still there are many views. First of all, that what artificial intelligence is, right? So the simplest view I read and heard is, they say that let's divide the problem in three. You have an input, you have an output. In between, there are choices. How you make good choices is what is artificial intelligence. And a very typical example given in books on artificial intelligence is the following, that there is a whiteboard. I need to write on the whiteboard. I have 4 whiteboard pens which are lying there. That is my input. Only one of them is working. So, to write there. So what I will do, easiest way is pick one, try to write it. If it doesn't work, pick the second one, third one, and fourth one, right? That's how we'll do, and we'll call brute force of computing. Simply 1, 1, 1. So this looks simple. But imagine that there are 400 pens now. So what we'll do with 400 pens? So if there are 400 pens and only one of them is working, so what we'll do? So that's where they say that no, we cannot solve it by brute force, and this 400 can be 4 lakh, can be 4,000. So therefore, we need to have a view which is more than just brute force. For example, as human beings, we may look that which pen is looking the freshest one, right? And is not looking really the old one. So this is what we will incorporate. So this is what one school of thought is saying, that machines should be given this power to be able to do such things, and they are pretty successful in this. This is one view. Second is that they say that, okay, let's look at our brain. Our neurons are connected. Let's make a neural network, make the learning for the neural network, and pass that learning there. So there is multi-layers of neural networks, right? It's a bit complex, but we'll not be able to go in depth. But just to give you an idea, and if you are interested, you will anyway scan it and find it. So this is multi-layered neural networks. So where this network learns that, take the example, that if it has to recognize that in this frame there is a line, how it can recognize? It looks trivial, but is not trivial. To feel the difficulty, let's say that a computer has to recognize the handwriting. If it is very computer writing, it is pretty easy. A, B, C, it can see that. But if it is handwriting, and we have millions of people writing differently, then how to check it? If it goes pixel by pixel, then we are back to the problem of those 4 pens or 4,000 pens, right? So therefore, the key fundamental they say is we make those networks learn for a specific problem, and then once they have learned it, then in that particular field, they will be performing a good job there. Is semiconductor companies doing something there? Yes. Answer is yes. We are developing chips which can do this kind of neural networks. Then we can have the software running on that. So it means what? That at the end, these kind of devices can be plugged on IoTs, and our things can become smart things in true sense, because there would be artificial intelligence. Take the example, we are all watching set-top box at our homes, right? Now, let's say that there is a smart set-top box. It knows that what you watch, when you watch, what your wife watches, although it may not be able to know is your wife or not, but even that can be done. We can put the vision in the computer that it is in the set-top box, that is your wife or you. So it learns in due course of time that this is your typical pattern. Whenever an advertisement comes, you shuffle the channels. And when from this channel, you go to this channel. So it learns. And then it starts to do all those things automatically. Right? It learns and it does it. So it becomes smart set-top box. Right? So those engines pretty soon would be in the hands of designers, developers to really make the things very smart. And therefore, we will see that this artificial intelligence really comes once again in the mass use. Otherwise, what I learned, that this was used way back in 1950s during World War II. So it's not something which is new. But the only thing is that now the technology will make it available to majority of us, which was not the case before. Finally, my last slide on India. I believe that this IoT is really a kind of opportunity which we can catch the bus. Otherwise, in India, we were always late. Whatever was being done, it was, coming later. There are many things on the top, you can read it, that are present there. There are IT companies, there are software people, there are services companies, there are semiconductor embedded software developers. We do less electronics manufacturing or system, but that can be plugged. But other elements are there. And I was there in Bangalore last 2 days, and there, I must share with you that I was surprised there are startups who are developing really artificial intelligent engines, IPs on that, which is happening almost contemporary. I am sure that if I will go to Silicon Valley, I will find something similar happening there. So it's first time I see that such things are happening almost at the same time, and therefore is a great opportunity. What we need is to collaborate more among ourselves, not to remain in our silos, to see that how we can unleash the power of each other and make this at least the opportunity to come where to grow our country here. So that's all from my side. So thank you very much. I hope it will give you something. Thank you.